In this example, we'll be doing static motor starting, the input data required, as well as the motor starting study case. We're going to replace lump 3 with an induction motor rated 500 horsepower. Let's go to the nameplate page, type in 500 horsepower. ETAP automatically fills out the remaining nameplate information. Let's say the lock rotor current is 600. On our load model page, since we're doing a static start, we can put in an acceleration time of 2 seconds for non-load and 4 seconds for full load. The reason for the acceleration times is that we're more interested in the impact of the motor start opposed to the acceleration time of the machine. Now let's switch to the motor starting mode and edit our study case. In the motor starting study case, you can essentially define sequence of events. We can add the first as event 1 and specify the time as it occurs. We can now define the actual action for this event. In this case, it will be starting motor 1. The total simulation time should be extended. Let's say to 10 seconds since the motor will take 4 seconds at full load. You can now run the static start by clicking the second icon in the motor starting toolbar. The program may display various alerts, critical or marginal, which you may investigate. A motor sliding time starter will appear. This slider allows you to select specific instances you wish to analyze. We'll start this motor at t equals 1. As we increase the time, you can see the inrush current being drawn by the motor. After 4 seconds, this motor reaches rated speed and starts drawing full load amps. You can see the same results with the help of a plot. Select the device type as motor and one of the various plot types. You can choose to select just current and voltage and then click OK. As you can see, at t equals 1, the voltage drops, and at t equals 5 seconds, it recovers, indicating the motor has finished accelerating. The lock rotor current starts at 1 second, and the full load amp is drawn at 5 seconds. Now let's switch back to edit mode. And we're going to pick a sync motor at 100 horsepower, and the amp, power factor, and efficiency, we're going to have them based on NEC nameplate data. We are, however, going to change the lock rotor current to 575% of full load amp, and the acceleration time with no load connected, we're going to have it at 1 second, and with 100% load, we're going to select 3 seconds. Once you've entered the nameplate and acceleration time for static start, we can switch back to our study case to add another event to start that motor. This will be a separate event starting at t equals 2 seconds. Now let's run our motor starting one more time. Again, with the help of our time slider, we can navigate through our results. So at t equals 1 second, motor 1 starts off, and at t equals 2 seconds, the synchronous motor starts. As I mentioned before, both of the machines can be viewed with the help of plots. We can look at the plots for the individual bus to which both motors are connected. And you can see the two steps representing the start of two different motors.